So yesterday we have seen like what is a thread and how do we create a new thread and how do we start the thread. Now and we know we discussed on how what are different ways of creating the threads by using the runnable interface or by just using the thread class. And with the run method, you can simply invoke you can simply start the thread. Now let's let's say I have a simple thread join class. It is extending thread class. So if my class is extending a thread class, that means thread join will have all the methods inherited from the thread class. So I insert a simple for loop here and I put a thread dot sleep. So thread dot sleep means we are asking the thread to sleep for 2 seconds. That's called a timed waiting state. So where is this? Just a minute. Java class for just a minute. Let me check this one. So if you want to put a thread into a waiting state, you simply use the timed waiting state. So for that, you just ask the thread to sleep for 2 seconds. And then let me create a main class out of it. So whatever we are discussing now is called the thread join. The statement ensures that TH is finished before the program does the execution of the next statement. Where there are more than one thread invoking the join method, then it leads to overloading on the join method that permits the developer or the programmer to mention the waiting period. So this is just a generic statement. And let me just execute this statement. You'll get to know um, why we need all the join and the sleep state. Just say the execution times.
So in the main method, we are using upcasting.
Upcasting where this
Thread
one?
join. Yes, I mean inherit. Yeah,
No, we're just creating an object of thread join.
it's not normal object. Okay, okay.
Yeah.
Yeah, yeah, yeah.
So I'll create 3 threads here. Okay. TH1,
Yes.
TH2, and TH3. These 3 are 3 threads.
Yeah.
Then I'll simply start the thread 1.
Yeah.
Okay. Now starting the second thread after when the first thread TH1 has ended or died. So see the current thread. The current thread is in main now. Okay. I mean, we know that for a particular Java program, um, there is at least one thread running because what is it? There's a Java process. So there will always be one thread which is by default running. So let's call it as a main thread. Okay. So so if you see the statement, thread dot current thread dot get name. With this, you're trying to get the name of your current thread. So currently, whatever thread it is running, that is your main thread. After that, I'm going to join my thread 1 to the main thread. So th1 dot join, meaning this waits for this thread to die. So once your main thread dies, then your th1 will come into picture. Like it will start. It will start executing its own flow. Similarly, start your thread 2 and then join your thread 2 with, and I'm simply use a join method, th2 dot join. what this will do is this will wait until your thread 1 dies. So let me use a debugger point here. Okay. So now I have initialized 3 threads, th1, th2, and th3. Now I'm starting my th1 thread. I'll click on F6. Now if you see, the current thread is main. We are in the main method, and currently my main thread is running. Now what I'll do is I'll simply join the th1, the thread 1 with the main method using the th1.join. I triggered F5. It's waiting for execution. So, just a minute.
So in Java, calling function is in main method and called function is in class, right?
Yes.
So this
So
is the hierarchy of programming because that was my doubt yesterday. Like we can't create object in class, only we can create in main method so that JVM will respond us, right?
no. The actual idea behind the actual behind the main method is if you want to make a program runnable, you need to have a main method.
Okay.
So for our ease of access, instead of me creating a main method within the same class, I'm creating a different class and I'm putting my main method here in the different class.
Mhm. Okay. So whatever the problem, the first thing we need to do is create the main method. Then only programming gonna be run, right?
Program will be running. Yeah. So whatever. Yeah. Take it that way. Yeah. When I'm discussing about the Spring Boot concept, then I'll tell you like what exactly the main method will be doing.
Okay.
But in a current scenario, since we are working on a single template file, that means this doesn't do anything, right? Like I'm just creating a new thread and I'm waiting for the previous thread to die. Okay, the debug is not working here within our within that concept. I'll simply execute the main method itself. See, the first thread is the main thread. After 2 seconds, thread 0 started. After 2 seconds, thread 1 died and it came to main method. After 2 seconds, thread 1 came into picture. Then again, after 2 seconds, thread 2 came into picture. So if you see the execution, I simply created some threads, and I'm simply invoking a join method. Meaning, let me take you to the PPT. When the method is invoked, the current thread stops its execution and the thread goes into wait state. The current thread remains in the wait state until the thread on which the join method is invoked has achieved its dead state. So that is what we are trying to achieve. If I invoke a thread th1.join, that means my current thread has become the first thread th1. Now after my thread 1 reached the dead state, that is state number 1, again my current thread is main now. After that, I executed the thread 2. I just started it, and again it triggered a join on it. That means now my main thread will be interrupted. The second thread will start. That's why you got this thread 1 with a 0 state. It is starting, and after it dies, it will simply go and pick up the third thread. So all this functionality, like this is a simple functionality. Like why do we need to use a join? So for if you're working with multiple threads and you want to execute a simple thread on top of your different running threads, you'll invoke a join method. So this is a complete functionality. So I can put it directly in a main method. But in your real industry coding, you won't work with main methods this way. So main method will be given only in a single class. Like if you're working with Spring Boot, there's only one main method which will be written in one class itself. That I'll tell you in the next 15 minutes. And whatever is whatever class and objects which are going to create, everything will be created within the package. So so till date what we're learning is we're just learning the basics and the concepts, like how to use what and when to use what. In the actual Spring project, you'll get to know what exactly we are going to work on. Is it clear? Like you asked me whenever there's a main method in the class, we create only objects in the class. But whenever we are going to work with other things, we don't create any objects. That was your question, right? But that's not the actual case. Because we are learning it line by line, I'm creating it within the class itself. But in the actual coding, it follows a different structure. So now, is the join concept clear for you? Like, why do we use it join? Yes, no?
Yeah.
Yep, okay. Then, so join. Next comes a thread pool. So the Java thread pool represents a group of worker threads that are waiting for the job and reused many times. So take your thread pool as a what you call as a pileup of your Java process. So you have lots and lots of Java processes and you put them in a small pool, and based on their execution time or based on their activation state, you simply release each and every Java process. They'll do the work and they'll die. So you can take it in that way. So it's a group of worker threads. Worker threads meaning the threads which are currently working and which are ready to work. So in case of a thread pool, a group of fixed size threads are created. So yesterday, after a class, we're discussing, right? Like how do you fetch 1 billion or 2 billions of records? We discussed that, okay, we can create a thread pool of 10 threads. So each thread will fetch some 100K records. Based on that, our execution time will be reduced. Similarly, that concept is implemented by using the thread pool itself. So it is a group of threads, and you're going to fix the size of the threads. So if you type something executors equal to executors dot create collection pool of 10, that means you're creating a collection pool of threads of count 10. So a thread from the thread pool is pulled out and assigned a job by the service provider. After completing the job, the thread is contained in the thread pool again. So this one. It will be very difficult to understand. I have also given the notes here. Let's just simply check the output. Now, let's see the output. Initialization time for the task name of task 1 is 5:36:30 seconds. So at 5:36:30 seconds, my task 1 is initialized. Next, task 3 is initialized. Next, task 2 is initialized. Okay, take these 3 tasks as 3 threads. So my task 1 will retrieve some 1000 records. Task 2 will retrieve 1000 records. Task 3 will retrieve 1000 records. So to pull up 3000 records, I'm creating 3 threads. Take it in this way. Now, now I have my main method. See this, creating 5 new tasks using the runnable interface. I'm creating 5 tasks, 1, 2, 3, 4, 5. Now, executor service P1 equal to executors dot new fixed thread pool. So you're creating a thread pool with the fixed number of threads. How many threads? 3. I defined the value as 3 here. If I define the value as 3 here, this will work fine. But tomorrow, if you want to change your source code, you need to change this value everywhere. If you put if you assign this variable to max th, this max th value can be used anywhere in the source code. Correct? See now, if my max th value is used 100 times within my source code, like let's say, you have these lines 100 times within a source code. So for each and every line, you can't put the value as 3. And now see, tomorrow, if I want to create a new fixed thread pool of a size number 5, what I should do is I need to change this value from 3 to 5. How many times it is declared? I need to change these many times. Instead of that, simply assign this value to a variable. Because you're working on a static method, put the variable as static, and you don't want to change the thread pool size, put it as final, and simply assign the value. Now this max th value will be assigned everywhere. So just with one variable change, you're achieving whatever you want. So this is a good variable usage, right? Declaring a right variable with a right accessibility will also counts for a code reusability. Now, what did I do using the executor service? Executor service is a interface. Okay, so with this interface, I'm creating a new fixed thread pool of size 3. That means whenever P1 is executed, it will create 3 new threads. Only 3. But how many tasks? How many tasks I have? I have 5 tasks to do. Task 1, task 2, task 3, task 4, and task 5. Now, for the very first instance, 3 threads will take 3 tasks, 1, 2, and 3. So they started at 5:36 p.m. Then the respective task took this much time to complete. After 5:36:35 seconds, my task 3 is complete. Then task 1 is complete. Now if you see the second line, installation time for task 4 and task 5. That means as soon as the task 3 is complete, the thread pool is released. As soon as the task 1 is complete, 2 threads, task 3 and task 1, 2 threads are released for me. Since 2 threads are released, now we have 2 more tasks to be triggered. They are picked up by those two threads. And they'll be executing, and at last task 4 will be complete. This would be a bit difficult to understand, but the only idea behind this is what is usage of thread pool. You have 5 tasks to accomplish, but you have only 3 threads to work on them. So the 3 threads will work on first 3 tasks till here. After task 1 and task 3 is complete, that means 2 out of 3 threads are free. Then I completed 2 of 5 tasks. So now I have 2 threads which are empty, right? So they will pick up task 4 and task 5. And during the execution, my task 2 is complete. So 3 of 5 tasks are complete, and two threads are already in execution. and at 5:36:41 seconds, task 1, task 4 is complete. That is the main idea behind the thread pool. You have how many ever tasks you want, you just put them, just define your own tasks and define your thread pool count, and based on the task execution, each and every task will be executed. Is this clear? So you need to understand the whole.
Again,
Sorry,
come again, exact meaning of thread pulling.
exact meaning of thread pooling itself.
Like you explained, right? Say here, yeah.
Yeah, see, in case of thread pool, a group of fixed size threads is created. So this is the first statement. What is a fixed size? 3. So I have created a group of 3 threads. So I have total of 3 threads. So how am I going to create a group out of it? Using this line. Execute a service, create an object of execute a service, executors dot new fixed thread pool. So this is a simple syntax. Like you need to, like, you can just simply memorize it, or whenever you're writing, if you know how to use execute a service, you can simply write this line.
Like in collections, we use primitive data types. Now here using for after new keyword fixed thread pool, right?
No. Executor service. So from the executors class, you have something called as a new fixed thread pool method. If you open this is coming from your executors class.
Okay.
So what it will do? So if you see the method, the method body, it is returning a new thread pool executor with how many threads, whatever is the value. So I'm passing, let's say I pass 3 value, right, in the method. So this will create 3 threads for me. Understood the line? From the executors class, you're calling up a new fixed thread pool method and passing you're passing a thread pool count. Okay, so now
Yes.
a group of fixed size threads is created. Then a thread from thread pool is pulled out and assigned a job by the service provider. So what is the service provider? Like, let's say I have like, using the runnable interface, I created 5 tasks. 1, 2, 3, 4, 5. Okay. After creating these 5 tasks, now I need to get the 5 tasks done with 3 threads. Get 5 tasks done with 3 threads. Now, so I have only 5 threads, 3 threads with me, and I have 5 tasks with me. So what my executor will do is, the service provider, it'll assign the 3 threads to first 3 tasks, 1, 2, and 3. Hence, now task 1, task 3, and task 2, both all the 3 tasks are initialized. So after a particular amount of time, task 1 and task 3 is complete. That means thread 1 is executing task 1, thread 2 is executing task 2, thread 3 is executing task 3. After some amount of time, task 1 and task 3 is complete. Hence, thread 1 and thread 3 are idle now. Now what is the statement telling? A thread from thread pool is pulled out and assigned a job by the service provider. After completion of the job, the thread is contained in the thread pool again. So now let's say thread pool. So my current thread pool count is 0 because all the 3 pools are running. Like thread 1, thread 2, thread 3 is running. Now, after task 1 and task 2 is executed, if I get the thread pool count, it is set to 2 because thread 2 is running on task 2, but thread 1 and thread 3 are complete already. So my thread pool count is 2 now. So I have 2 tasks already waiting here, task 4 and task 5. So these 2 threads will be assigned to task 4 and task 5. That's why as soon as task 3 and task 1 is complete, immediately my task 4 and task 5, they went into initialization state. That means they're executing. So after, like, in the meantime, like whenever the 2 threads picked up task 4 and task 5, my task 2 was complete. That is complete. So my thread pool size would be 1 now, because 2 are already running, right? Task 4 and task 5 running. So those 2 threads are in running state. Now thread pool says I have only 1 idle thread. So after some time, task 5 and task 4 is complete. So again, at the last, my thread pool size would be 5, 2, 3. At last, after everything is executed, I'll simply shut down the thread pool. That means I shut down all the threads. The main motive behind this is how many tasks you have. You have only 3 weapons. With these 3 weapons only, you do those tasks. So how to do those tasks? This way. Run the first 3 tasks. After some tasks are executed, run the remaining tasks. Is it clear now? Durbabu, Uday, Mahalakshmi, Asha.
Yes.
Okay.
Yeah, slowly getting required some practice.
Yeah, this requires practice.
Even yesterday's class also, it's not easy. It's not.
Yeah.
This thread count concept is quite compared to collection framework. I mean, the previous
Yeah,
concept.
yeah. Those are simple concepts. Like these are rigorously used within your programming. So when you start coding them, right, it will be easy for you.
So threads are very important during real-time projects compared to the connections.
Each and every concept is important, like whatever which we're discussing, because this is only a 3-week course, right? Whatever topics are important, only I'm like we're discussing here. There are lots and lots of other topics, but these are the topics which will be rigorously used within your applications.
Yeah.
Okay. So what are the risks in Deadpool? So deadlock. It is a known fact that deadlock can come in any program that involves multi-threading, and Deadpool introduces another scenario of deadlock. So now since we are working with only three threads, we didn't face any issue. Tomorrow when you're working in a real world applications, and let's say here task number 2. Now in task number 2 is being executed by thread number 2. So if there is any exception in task number 2, and if that is not handled correctly, my thread 2 will be in running state only. Like it will never become idle. So because of thread number 2, if you link it up with thread number 3 or 1 or any other threads, what will happen is all the threads will be in idle state now. All the threads will be in running state only. Like they will not terminate. So your remaining tasks will be incomplete. That state is called as a deadlock state. Like you cannot move forward, you cannot move backward. That is your deadlock stage. That's only a risk in the thread pool, but if you hand it correctly, then no issue. Next is a thread leakage. Leakage of threads occur when the thread is being removed from the pool to execute a task, but it is not returning to it after completion of the task. Just a minute, getting a call. Just 1 minute. Yeah, sorry about that. So now if you see this execution, by initial thread pool count is 3. After the 3 threads went into execution state and the thread pool count is 0. When task 1 and task 3 is complete, my thread pool size is set to 2 because whatever threads went went into running state, those are returned to the thread pool. Suppose in the event where your thread is not returning into the pool, that is called as a thread leakage. So even that can be handled. Yeah, so leakage of threads occur when a thread is being removed from the pool to execute a task, but it is not returning after completing the task. That event is called as a thread leakage. And resource trashing. A lot of time is wasted in context switching among the threads when the size of the thread pool is very large. So just take a simple example. As soon as my task 3 is complete, my task 4 did not come into initialization state. It took some time and task 1 is complete. After that, task 4 and task 5 got into execution state. So if I'm working with only 3 threads, I'm seeing this small difference. And imagine when you're working with large number of threads, um, there'll be a large differences within your resource sharing itself. Like one thread releasing the process and again going to the thread pool and again taking the new task. So a lot of time will be wasted in context switching. Next comes garbage collection. So garbage collection is the process of reclaiming the runtime unused memory automatically. In other words, it is a way to destroy the unused objects. So whenever you have a process or whenever you have a simple Java application, after completing the complete execution, okay, let's take a simple web application. Your web application will always be running on your server. So after a particular amount of time, many code, like if everything is handled correctly, there won't be any issue. But many of them, what they do is they just simply initialize a variable, declare them, and they use it for they use it for some calculation, and they simply like they won't even unreference it. Like they don't even destroy the object. So what is the effect on them is each and every variable will be initialized multiple times, and when you're initializing multiple times, that amount of space will be occupied within your heap memory. Meaning, whenever let's say at 5:45, my heap memory is 1 GB. Like after 5 minutes, some thousands customers simply click my application. With that, what will happen is 1,000 times those variables are declared, and my heap memory will change to heap memory will increase to 2 GB. Imagine you are on a server with only 8 GB of heap, and if you don't clear these unused variables, just like within 1 hour, the heap memory will increase to 8 GB, and with no heap, your server will automatically shut down. That is the catastrophic disasters what you can expect. Like if you don't garbage collect the objects. So it makes Java memory efficient because garbage collector removes the unreferenced objects from the heap memory. It is automatically done by the garbage collector. So we don't need to make any extra efforts. It is automatically done by the JVM. So we need to know, okay, what is doing it and how it is doing it. That's why I kept it in this PPT. So these are the process, like how to unreference all those objects by using the finalized method or using the GC method. Simply show them. So I simply just created a finalized method here, and void main garbage collection equal. I've just created two objects S1 and S2, and I'm referencing S1 and S2, but these are not used anywhere. I just initialize them to null, and if I type the system.gc, this will run the garbage collector on the virtual machine. So system means it is coming from the java.lang.system package. This is a class. Within this class, I have the GC method. That's the garbage collector method. If you see the Java doc, this will run the garbage collector on the JVM. So calling the GC method will suggest the JVM to expand the just expand your effort on clearing all the unused and unreferenced variables. Simply run it. Done. It'll clear everything. So this is automatically done by a JVM, but you need to know, like, since we are not explicitly doing it, but you need to know that, okay, JVM is doing something to unreference all the unused variables. Okay, this is not required for this class. So like we have completed almost all the concepts behind our threads. If like we have 2 minutes, like if you have any doubts, you can ask me now. Obviously, this is a complex topic, so you need to keep on like I'll push the whole source code. Just refer the videos and keep on practicing them. Then you'll get to know, okay, what is the thread, what is the state, what is the name, why do we use it, how to use it, and everything. Yes, any doubts? No doubts? Okay. With this, let me start something called as Spring Framework. So most of applications, like within the current world, they are building applications on Spring Framework. So what exactly is Spring? It's a lightweight, powerful.
Bhavesh,
Mhm.
actually, this Spring framework, let me know about what is the Spring and what is the Spring Boot, because you said right few annotations.
Mhm.
So this framework consists of full of annotations, right? I heard that, so that we no need to write the whole code, so that this annotation itself generates the piece of code, so that we can reuse that one during the programming. Am I right?
Right.
Yeah. Please go ahead.
So Spring is a lightweight, powerful application development framework. So you use it for your application development. So it is called a framework because it is a framework of frameworks. Okay. I provide supports to various frameworks, Hibernate, Struts, AJP, JSFs. So all these are Java frameworks. So to support all these frameworks, you have complete framework to support these frameworks. Hence it is called as a Spring. Like the wording itself, Spring framework, a framework which will support all the Java frameworks. So in most of interview questions, they'll be asking what is the current Spring version which are working and what is the current Spring version. It is 4.3.8. That's the Spring version. If you see the features, it is lightweight. So how can we, like, how are you going to work with Spring? That is inversion of control. Inversion of control means,
So once can you go to backslide, previous slide?
okay,
Over there it says that various frameworks, Hibernate, Struts, Tapestry, EJB,
yeah,
JS. So
yeah.
so for each and every Java programming, so what is a major usable framework by major companies?
Just a minute.
Spring or
Let me tell you this way.
You mean framework which support all the Java programs, right?
yes, applications, yes, current.
See, let's say, okay, let's take a Tetra Computing itself. So now, if you want to know more about Tetra Computing, you have something called as a tetracomputing.com website.
Okay.
So how do we hit the URL? Um, should I- See, this is a simple application, simple application meaning like a web page. Whenever I hit tetracomputing.com, so this is a URL. So this URL is recognized all over the internet. So whenever I hit this URL on the browser, this will in turn trigger my application.
Yeah.
Right. If you see the network trace also here, this is the request URLs. You'll get the response. So whatever we are seeing, these are called the developer tools. Okay, I'll tell you in detail like what are developer tools and what they'll be doing. So if you work on a simple Java application, like there's a URL. That URL in turn, this URL in turn will go and click my it will hit my application. It can be Java, it can be React, Angular framework, anything, some technology. Now that application the within that application, this application has a whole source code. Take this as a main app. Okay, take this as a main application. So and like if you put all this data like about Tetra, the services, everything within a main application, tomorrow if you change your if you want to add something, you need to add it in the main application, right? That means you need to touch the code, correct?
Yes.
So let me give it in this way. See, let's say a simple example, thread T equal new thread Tetra. Tomorrow if I want to change the name of this, I'll simply change the name here, build my application and deploy it on the server. Again, day after tomorrow, client will come with one more requirement to change the name to some other name. I again need to come here, change it, build it, and deploy. So how many times ever you want to change, you need to make a change in the source code. That is always a bad practice. So what if you put this value in a database? Simply you'll go and change the database value, and if you write like I'm not giving the exact syntax, I'm just putting a statement. Okay, select star from schema dot table name where name equal to put something. Okay, so if I execute this query, I'll get the value of this and string name equal to, this is not the exact syntax, but I'm just giving an example. Okay, if I pass the name here, that means if I change my database value, automatically this value will be changed. So I did not touch the code, right? I did not make a deployment. I only need to change the database value. Hence, all our real world applications will have a database to manage all the data. Database. Now, what your application will do, from the database, you'll have lots and lots of values within your database. So it needs to fetch the data from the database, perform all your operations, and again store them in the database. It's a to and fro process. From the URL, your application users will hit your application. Your application will hit the database. It will get the data. Database will provide you the data. So with the data, whatever you want to do, you'll do with the data, and your main application will give the response to your URL again. From the server, it is sent to the end user interface. This is the flow. Is this clear? A simple flow. Just put in a chatbot or a chat box or speaker.
Yeah.
Yeah. Now, since you know these three concepts, what you can do is uh, the very take the very first layer, take this as a server layer, because here you have a URL, here you have a server, uh, and and there are many things like you need to do a DNS lookup. You need to take a lot of measures on the networking. So take this as a networking layer. This full layer as networking layer. And whatever application which you're going to write, that is there in your application layer. And whatever database operations you want to perform, put them in your database layer. So tomorrow, if you have any issue in your database, only this module will be touched. If you have any issue in the application layer, only this module will be touched. Thereby, uh, you are making these all these components independent. Correct? Like let's say if you have networking layer and database layer within your application layer itself. So if you want to make any change, you always need to touch your source code. Correct?
Yeah.
Yeah. So we don't want that. In Java, always you need to achieve loose coupling. Loose coupling meaning everything should be independent. So they should, like the dependencies should be very loose, very loose, so that whenever there's a small modification, you only need to do the desired change. You need to touch everything. So if you take the example of Hibernate comes under database section. So you have Hibernate, you have JPA, you have ORM. These are frameworks. So if you're trying to use something with Hibernate, you're working with database. If you're working with struts, struts struts. So this has struts config XML file, and this has action classes. This maps responses from like forward like this forwards all the response from action classes to front end JSPs and JSFs. So that's again a different framework. So that will come under the application layer framework. EJBs, JSFs. So EJBs will come under again like they're sitting in between the application layer and the database layer. JSFs, Java Solid Faces, they'll be coming under the front end layer. They serve as the front end frameworks.
Okay.
So whatever framework you see here, those are present within these three layers only, right? Like these three are like I provided a generic layer, okay?
Yeah.
Like there are many layers. I provided a generic layer, but whatever framework you take, everything is present in these only, right? Network,
Yes.
application, or database. So to support all this, there is one framework. It's not the only framework. It is one of the framework called Spring, which will support everything: networking, application, database, everything. So it is a framework of frameworks which provides support of Hibernate, Struts, Tapestry, EJB, and JSF. That's the meaning. Clear?
Yeah.
Yeah. So the annotations and everything, yeah, we'll discuss in detail. So what are the features? It is lightweight and inversion of control. Loose coupling is achieved using inversion of control. The objects give their own dependencies instead of creating or looking for dependent objects. So previously, like whatever we discussed till date, you're creating your own object of the class, and with that object, you're going to do all your operations. But with inversion of control, IOC, whenever you run your main application, everything will be injected automatically in the runtime. Thereby, you need not create an object of your parent class. It is automatically done by IOC, inversion of control. So that is done by using the annotations itself. At that AutoWare is the annotation. So when we're discussing about annotations tomorrow, you'll get to know how that is done. So the main the like when wherever the like within your interviews, if you are having a question, okay, what is the main advantageous feature of Spring? That is IOC, inversion of control. Previously, you are creating the object and using the object, but now that object will be given by a Spring container, and you'll use the object. Reverse, you creating it by yourself and using it. Spring creating an object and giving it to you in runtime. That is called inversion of control. You're simply reversing the control of your object execution. Next comes our aspect-oriented programming, separation of business logic from the system services. And take this again simple example. My like if you take the application layer, my whatever logic which I want to play with the data, I'm putting in application layer, and whatever data I want to store, I'm putting in database layer. So within application layer also, I can separate them based on my types. That is called as aspect-oriented programming (AOP). These are most frequently asked questions within your interviews. What is IOC and what is AOP? Separation of business logic from the system services. Transaction management. So in Java, if you're talking some, if you're talking like if you're using the term called transaction, that means you are working with database transactions. So if you're pulling data from database, get the data. If you want to upload some data into your database, put the data. Or if you want to modify something, modify the data. If you want to delete a record, delete the data. So all these are called as transactions. Perform a transaction to get a data. Perform a transaction to delete a data. So everything is provided by Spring and containerization. So this I have given a single word here, container, and I'm going to explain them like when we're doing our live coding. So, so this is the most common image which you'll be seeing when you're working with your Spring frameworks. Like each and every tutorial over the internet will have this. And this is in the Spring.io. Spring.io is the official website for your Spring tutorials, and whatever work you want to do with the Spring, simply go to navigate to Spring.io, and you'll get lots of documentation there. So here, the first thing is your core container. Like whatever we have discussed in the feature called container, the container will have beans, core, context, and expression language. On top of it, you have your AOP, the aspect-oriented programming. On top of that, you have the web, and you have the data access integration. So you can like 1, 2, 3. Just take these three modules: core container, web, and data access and integration. Now see this. If you see Tetra, that is that is just a simple web page, right? This is a simple web page. So for the viewers, like for the users to see this web page, there's a lot of coding behind this. So you need to have a lot, like there are many front end technologies which are used to achieve this home page. So this is called a front end. Whatever users see is called a front end, UI, user interface. So with this user interface, I'm going to access each and everything. Next is a backend. Backend means whatever logic. Like if I click on this training, I'll get this drop downs. If I click on RPA training, it'll take me to some page which has this data. So how to provide this data, what data to provide, everything will be taken care by my backend. So that will be there in my application layer. So now if you see this, front end is there in your web protocol. In the web runtime, the front end sits here, this one. And whatever data you're getting from the database, that is sitting in a data access, JDBC, ORM, OXM, JMS, transactions, and everything. And combining web and data access integration, you'll be like you have the data and you have the front end framework to visualize the data. But if you want to do some operations on your data, you need something called as the core container, beans, core, context, expression language. This in a simple nutshell, like how are we going to work with Spring? So take this as a key. What is RPA? If you take this as a key, TRPA allows automation. This is the value. If you take this as the value, this value will, like obviously I cannot keep this much text in my Java source code. So what will I do? I'll put this value in my database. And if I pass like something like if I pass this RPA training as a key, I'll get this response. So I'm going to visualize this response in my front end. From the database, I'll get robotic process automation as the response. and I'm going to give it to my front end. My front end team, what they'll do is they'll put the heading as bold, and they'll increase the font size. They'll simply put a break line here, and whatever is the text which is below the RPA, they're going to gray the color. So all is the front end operations after getting all the data. So it is the duty of our uh, of your application development team to provide right data to the front end. So instead of RPA, if you give some other data, what they'll do is they simply visualize it. Like instead of RPA, if you provide a like if you provide automation, they'll visualize automation only here. You need to provide correct data. How? By using this application layer. With this application layer, you do all the calculations, you do all the modifications, and based on them, you'll provide some data to the front end, and they're going to visualize it. So everything like a data access, web, and core container, everything is present within a Spring Framework runtime. So since it is providing support to JDBC, web, AOP, beans, core, context, this complete set is called as a Spring Framework. It is supporting frameworks, multiple frameworks within a single framework. Yeah, I think we are past 3 minutes. Tomorrow we are going to discuss on all the like what these layers are doing, and directly like we can get into direct coding itself, so it will be easy for you. Instead of we discussing on each and every annotation, I'll directly like write the codes and show you the outputs. So for that, you need to download all this Spring, Maven, Postman, and MySQL. I'm going to paste all these links within our chat window. So uh, just simply download them, and how to install if you have any issues, we can start like we will discuss in tomorrow's class. Any doubts still here? What is Spring and why we need to use Spring?
No.